The last time we looked at absolute value functions and talked about transformations, we looked at a function that looks something like this: y equals absolute value of x minus h plus k. And here's what we said. We said if we change the h value, that'll translate the graph either to the right or to the left. And of course, the other point that we made is that what does an absolute value function look like? Well, it tends to look like this. The two lines with arrows are the absolute value graph, and the other lines are the x and y axis. So anyways, if we change the value of h, it will translate this absolute value graph, the blue lines, maybe I'll make them a different color just to make it stand out. We take this guy, and if we change the h and the k, it will move to the right or to the left. Then the k, if we take this very same graph and we change the k value, it will translate this graph up or down. In other words, my v will move up or down on the y-axis. So that's what happens. That's kind of the basic case we talked about before. We're going to add something new in here. What happens if we have an a out in front? In other words, what if we have a number out in front of the absolute value signs that's being multiplied times the stuff inside? Well, that causes a couple new things. What happens is that number in front, it acts a little bit like a slope, and you'll see why in just a second. And if that number does act like a slope, then it's going to cause the graph to appear to stretch or compress vertically. To see what I mean, let's take a look at at Desmos. So in Desmos, here is y equals absolute value of x, and I'm going to try putting a number out in front. Right now there's an implied 1 out in front. Hopefully you guys realize that. I'm going to go ahead and change that 1 to a 2 and take a look at oh, by the way, with that implied 1 out in front, slope is, when we see 1, it really means 1 divided by 1. And so this has a slope, if you start at the origin, it has a slope of rise 1 and run 1, rise 1 and run 1. Not a huge surprise. Of course, the other part of the absolute value graph is just a reflection about the y-axis of the first part. So the slope applies to the part to the right, and then we reflect to get the other part. So let me go ahead and get rid of this. And by the way, we reflect about the line that goes through the vertex. The line that goes through the vertex could be off to the side. The vertex could be off to the side. It doesn't have to be at 0, 0. What about if I have 3? We'll notice we get a slope of rise 3, run 1, or 4. And I hope what you can see is that as we go from 1 to 2 to 3 to 4, it looks like the graph is stretching vertically. In other words, the 1 kind of looks like somebody with their arms out to their sides, and the 2 and the 3 and the 4 are somebody stretching their arms to the sky. What happens if I put a fraction in front of here? So I'm going to go 1 over 2. Well, it's still a slope. We rise 1 and run 2, rise 1 and run 2. And so that's how it works. And then, of course, we reflect about the vertex. Let's see if I put a 1 over 3 and a 1 over 4 and a 1 over 5. What's interesting here is as these fractions are getting smaller, my vertical stretch gets wider. Okay. In other words, there's less of a vertical stretch. So when I have a smaller fraction like 1/5, very wide. As the numbers get closer and closer to 1/2 or 1, I get more of a vertical stretch. And once I get to 1, and then go up to 2 and then 3 and then 4, I get more of a vertical stretch. So when this number a out in front of the absolute value gets bigger, our graph has a vertical stretch, and the a acts a bit like slope. Now, it turns out, one last thing I'll share with you, it turns out this works just fine if we also have h, and I'll put, for right now, I'll just put -1, and k, and I'll just put +2. It works just fine that way. I'm going to go and actually put a number in here. Actually, let's just leave it at 1 for right now. What we can see is that the original graph, y equals absolute value of x, that's located down here, If I do -1 inside the absolute value and +2 outside, the -1 makes me move 1 to the right, and the +2 makes me move up 2. But as far as the stretch still works the same way. Right now I have a slope of 1, and I go rise 1, run 1, rise 1, run 1. And if I change this to 2, then sure enough, I go rise 2, run 1, rise 2, run 1. And if I change that to 1/3, sure enough, I go rise 1, run 1, 2, 3. Rise 1, run 1, 2, 3. Again, notice the vertex is still at 1, 2. And by the way, this is something that I should point out for you guys for right now, is that the standard form of the absolute value function y equals a times the absolute value of x has a minus sign in it. And so it's always minus h. And then we do, on the outside, we do plus k. And so what happens is if it's minus a number, well, if we're looking for the vertex is always going to be the opposite of the number, the opposite sign of the number inside, and the same sign as the k. So the vertex here is going to be 1, 2. And sure enough, I get a green dot right on the vertex. If I change this to +3, x plus 3, and I change this to -5, actually let's do -1, and let's get rid of our slope, then what we end up with is, well, let's see. I am predicting that we're going to use the opposite sign of this 3, so we'll do -3 for the x. For the vertex, and then comma, and then the same sign as the k, so we'll do -1 for the k, and sure enough, I get my green dot on the vertex at -3, -1. All right, so that's the main concepts that I wanted to get across to you for absolute value functions. You can translate the graph right and left and up and down using h and k, and then you can make the graph more thin or more wide using a, and a acts a lot like slope. Okay, with that knowledge in mind, you guys should be able to graph an absolute value function if I give you one. So I'm going to give you one, and let's just see what you guys can do with this. Let me go ahead and turn this off so we can't see what it's going to look like. And I'd love it if you guys could graph this by hand. If you want later, try Desmos. But what if I do something like this? -2, and we do +3, and what the heck? Just for the heck of it, I'm going to put a 4 out in front. I would love to see it if you guys could graph that. Maybe we'll talk about that in class tomorrow.